poverty, hunger, and disease. These three ancient enemies of man still stalk hand in hand across too much of the world. Of the three, disease can be said to be the most deadly. Disease often fathers hunger and poverty. This is the story of how one of the mightiest weapons against disease was forged. It is the story of penicillin, the first of the modern wonder drugs known as antibiotics. Today, the penicillins are only one group of antibiotics among many, and in laboratories throughout the world, the search goes on for more. To learn how the first of them, penicillin, was discovered and developed, one must know of the work of three British scientists. What they achieved has revolutionized medicine. Sir Alexander Fleming, for the initial discovery of penicillin. Dr. E.B. Chain, and Sir Howard Florey for their finding its curative power to benefit millions. Early in the 1920s, in London, Alexander Fleming, a young bacteriologist, worked in the inoculation department of St. Mary's Hospital. Familiar with antiseptics and inoculation as weapons to help the human body battle against disease germs, he began to wonder what natural defenses might be possessed by exposed parts of the body, such as the eyes. In each place, Fleming found a protective substance which could destroy some germs before they invaded the body. Some germs, but not all, and not the most deadly. In one of the glass dishes where he cultured germs for his experiments, Fleming noticed one day in 1928 that some mold, such as appears on decaying food, had begun to grow. A spoiled experiment. But with mind alerted by the earlier work on protective substances, he looked closer. He saw that near to the mold, no germs were growing. Might it be that this mold, like the human body, produced a substance capable of destroying germs? He made tests and found that even some of the most dangerous germs died near to the mold. He then grew the mold in a meat broth liquid. The color of the liquid changed finally to a bright yellow. This liquid proved lethal to germs, even when greatly diluted. Not pure enough to be injected into a human body, it was nevertheless effective on wounds. Fleming published what he had done, calling his substance penicillin. Attempts to purify it and to extract its essence failed. In the 1930s, a new chapter opened at the University of Oxford. The professor of pathology, Dr. Howard Florey, was joined by Dr. E.B. Chain. Together, they planned a research project on natural germ-killing substances. They unearthed the now old papers on penicillin. They formed a team. The great quest was on. First, Chain and his colleagues set to work on the chemical problems of extraction and purification. They found a way of transferring the active penicillin from liquid to liquid until it was held within almost pure water. They froze off the water, which left a brown powder. Here was a powerful form of penicillin, still crude, but which produced no ill effects in animals. Florey prepared the great test. The germ Streptococcus is a killer. This he injected into mice. Half of them then received the brown powder. Those who had been given the penicillin lived and were healthy. And Professor Florey declared, "It looks like a miracle." But attempts to make it pure enough for man caused it to lose its potency. Chain and a colleague, Dr. Abraham, then devised another method. Dissolving the crude penicillin in ether, they passed it through a long tube filled with alumina, each substance producing layers of differing colors. In the yellow layer was penicillin. They repeated the process again and again. Now Florey could try penicillin on human beings. The results prove the healing power of penicillin. But by now, World War II was raging. The need for penicillin's healing power was enormous for soldiers and for civilians. But in 1941, purified penicillin was still desperately short, and Britain was hard-pressed by air attacks. To make the quantities needed, it was decided to seek help in the United States. Here, scientists devised better ways of culturing penicillin, which could give much bigger yields. Production in quantity could now be foreseen. With encouragement from their government, American drug companies tackled the difficulties of producing penicillin on an industrial scale. Florey returned to Chain and the others, able to look forward to supplies for further research. Alexander Fleming had a patient dying of meningitis. Fleming turned to Florey, and Florey gave him all the penicillin that could be made available, and with it, his advice. Profoundly impressed by this personal experience of penicillin's dramatic power, Fleming addressed himself to the British government about the need for large-scale production. And the press took up the cause. The big British chemical and drug companies and the research workers now also projected the big-scale production of penicillin. The mold was grown in thousands of flasks. Britain's output joined the huge supplies now coming from the United States to give life to hundreds of thousands of soldiers. By the end of the war, flasks had been replaced by great steel vats, each making 15,000 gallons of penicillin liquid, and huge factories were in production both in Britain and the United States. Penicillin was now for the world. Everywhere curing the sick, everywhere saving lives. But some deadly germs had forms which resisted penicillin. This was a challenge which research had to meet. In the middle of the 1950s, a famous British drug company set up a special team to work in close collaboration with Professor Chain. and in 1959, a breakthrough. This is the core, the main building block of a molecule of penicillin. Alone, it possesses no germ-killing power. But add other groups of atoms to it, and you make a penicillin. Add one group of atoms to it, and you make the original penicillin. Add others, and you make an ever-growing family of new penicillins. Some of these can tackle the germs which originally resisted, and some can carry the attack to germs not formerly sensitive to penicillin at all. And in the meantime, work has continued at Oxford, where yet another mold has produced yet another penicillin-like substance, cephalosporin C. This too has a basic core, which in turn can be used to build a family of antibiotics to carry further the attack against germs which formerly had resisted. All these mighty weapons against disease stem in some way from the forging of the first one, penicillin. The great discovery, for which in 1945 the world rightly and gratefully honored Dr. E.B. Chain, Sir Howard Florey, and Sir Alexander Fleming, pioneers in a struggle which promises now to drive back that ancient enemy, disease.